No question that human efforts, human activity that leads to increased CO2 emissions into the atmosphere is contributing to this rapid global warming. And what are the effects of this global warming? You might think that 1 degree rise in temperature isn't so much, but 1 degree already with our current warming, we have less water available, more drought, wildfires, floods, storms. With a 1 degree increase, there will be a risk of extinction for 20 to 30% of the known species, and most corals will turn white. With a 2 degree increase, there will be major changes in natural systems, widespread death of coral reefs, and millions of people will face flooding risk. With 3 degrees, there will be a substantial burden on health services, and 30% of global coastal wetlands lost, and a decrease of global food production. With only 4 degrees, more than 40% of known species will be extinct, and economic losses, GDP losses, will be up to 5%, and there will be at least a partial meltdown of the Greenland and Antarctic ice sheets, raising sea levels by 13 to 20 feet. And remember, those projections went all the way up to 8 degrees. This is a picture which shows you quite visually what is already happening with the Greenland ice sheet and coral bleaching. Science can and must help. There are all sorts of places where breakthroughs might occur that will help us solve some of these problems. But more than science is needed. We must, I believe, build an economic and political system that is not dependent on unlimited consumption and growth. I am very disturbed when I hear politicians, certainly in my country, talk about global warming, because they always say, we can deal with this problem and still grow and consume more and more and more. Politicians don't know any other way to appeal to the masses anywhere in the world without promising them more growth, more goods, more consumption. If we continue to base our societies on consumption, consumption, consumption as the ultimate human goal, then I think we are doomed, no matter how much we become energy efficient. We have to find some other way of building an economic system and a political system where politicians can run for office without promising more and more material goods. And finally, we must move towards a world government. We're all one family. The problems we face are of the planet as a whole. The economic system is more and more a world economic system. The idea of having 150 separate governments is crazy and is not going to last, I believe, that long. And we must move as fast towards a true world system as possible. And here's where science can provide an example of internationalism. You see, the problems posed by basic science are not posed by governments or national organizations or politicians. They're posed by nature. And in the pursuit of science, everyone is equal. So for that reason, basic science is and has always been a truly international endeavor. a wonderful model of cooperation, collaboration, and of course competition, which is important and useful across all nations. I found a letter that Einstein wrote to an organization right 1946, after World War II, when he was concerned about nuclear weapons, the atomic bomb, and how it could destroy civilization. And Einstein said, "The growing movement of a supranatural government seems to me the major hope of mankind. Only world law can assure us progress towards civilization, peace, and true humanity." We were lucky to avoid nuclear annihilation over the last 50 years, but we might not be so lucky to avoid what we're doing to our planet. And I agree with Einstein that internationalization is what is needed. So let me end with questions and predictions. Questions are absolutely important because I like to say that the most important product of knowledge is ignorance. Not ignorance of the type that leads to bigotry and racism, but informed, intelligent ignorance. That's what propels science forward. You see, knowledge is sort of has this geometry. We're embedded in a sea of ignorance, pushing our way out. And all of the interesting questions arise at the boundary between knowledge and ignorance. So the more we learn, the more knowledge we acquire, the better questions we can ask. And so one of the great resources of science is informed, intelligent ignorance, the questions we ask today that we hope will be answered tomorrow. And we have so many wonderful questions that we are working on in the basic sciences. How did the universe begin? That's a great and wonderful mystery. It now is a legitimate scientific inquiry which we are addressing. The universe we've discovered is full of something we call dark matter, which we can feel but not see. Most of the matter in the universe is in this form. We don't know what it is, and it is full of a form of energy, vacuum energy, that is causing its expansion to accelerate, and whose magnitude we do not understand. And all of those forces that we do understand seem to cry out for unification. How do they unify? Some of us are working on a wonderful attempt called string theory. Is it the answer? What is the nature of space and time? We are being led to question our classical concepts of space and time. In biology, one of the most fascinating questions that we're beginning to address is, how does consciousness, thought, emotion, free will arise from the collective behavior of 100 billion neurons? And many, many, many more wonderful questions. Some of these we will answer. We have wonderful tools to answer them. This is a picture of a massive new particle accelerator which is turning on in Geneva in Switzerland next year, and will help physicists understand, we hope, some of the many of the mysteries we still do not understand about the unification of the forces. In the case of cosmology and astronomy, we have marvelous instruments like the Hubble Space Telescope that we send into space to explore the universe. I'm going to end with a bunch of outrageous predictions. It's very dangerous to make predictions, but the business of scientists is to make predictions. So over a period of 50 to 100 years, it's easy for a basic scientist to predict that most of the questions that we ask today will be answered. I don't know how they will be answered. I wish I knew. They seem impossible, some of them, to answer. But history has shown us that almost any question in basic science we can ask fruitfully today is answered over a 50, 100-year period. So all those questions I asked before, except maybe how did the universe begin, that's perhaps the toughest, including the nature of the mind, will be answered, I am convinced, over this time period. But we will have even more interesting questions to ask and to ponder. Questions I can't even ask nowadays because I'm not intelligent enough. I don't know enough to be ignorant. But I also think that one of the major developments in this time span will be that as we learn how the human mind works, the social sciences, the political sciences, economics, the sciences that depend on human behavior might become real sciences. Quantitative sciences. Sciences that have a microscopic understanding to build on, in this case, how the human mind works. And that could have enormous advantages. It might enable us to move towards better and more rational societies with the application of the human sciences to human behavior. And with that, we might then be well on our way towards a sustainable economic and social arrangement and a world government. You know, the planet is 5 billion years ago. It's 5 billion years old. Life is 3 billion years old. Humans are millions of years old. So, it is always, I find it always interesting to imagine what will the world look like, what will we as a species look like in 1,000 years from now, which is a very short time, but unimaginable. There's no way I can predict the issues of basic science then, or technology, but I'll make some predictions anyway. What I mainly would like to predict is that the problems we face today, and which I believe we will solve, of sustainability and the threats to our environment, will be replaced by other problems that will also partly emerge because of our increased control over nature. Some of them won't be. There'll be the two-edged sides, two-sided nature of scientific advances. The first is increased lifespan. The human lifespan has doubled in 200 years. What will it be 1,000 years from now? Well, it's hard not to predict that it will increase by a factor of 10, maybe even more. That is wonderful. We would all like to have 10 lives, 20 lives. It's crazy to have a world in which we educate young people like you until the age of 25 and 30 years of growth and education, and then you work for 30 or so years and then retire. What a waste! An increase of lifespan by a factor of 10, I think, at least, is inevitable and desirable. But of course, it would have profound impact on the environment, on society, on our culture, and this would